Hi, today we're going to learn about binary numbers. Why, you may ask? Well, because your life depends on it. That's because everything we use in our day-to-day lives, from smartphones to computers or every computer device, works depending on binary numbers. But in order for us to understand this, we will need to start from somewhere closer to home. So, I'm assuming if you're watching this video, you are a human, meaning you have 10 fingers or 10 digits with which you use to count. Now, when we use 10 digits to count, we say we're using the decimal system. And in this system, we group whatever we're counting based on groups of 10 or base 10. As what we count gets bigger and bigger, we can group our base of 10 into larger powers of 10. And we denote large numbers using a positional system in which each digit represents a power of 10. So from right to left, we have units, tens, hundreds, thousands. These are all increasing powers of 10. Take a number like 7,255. Now, using our base 10 system, what this number means is we have 7 groups of 1,000, 2 groups of 100, 5 groups of tens, and 5 leftovers. Now imagine we had just 2 fingers. In this case, we'll be grouping whatever we're counting in groups of 2. And we call this the base 2 system or the binary system. Take a number like 5 in our decimal system. Now, 5 is just 2 groups of 2 and 1 left over in base 2. So from the right, we have our units place, and moving to the left, we go to our twos place, and to the left, we move to additional powers of 2. So from units place to 2 squared to 4 to 8, and we just double our units as we go to the left. So let's represent 5. 5 here we'll have 1 set of 4, no sets of 2s, and 1 left over. So 5 in base 10 in base 2 will be represented like this, since we have just 2 digits. That looks like 101, but that's 5 in base 2. Now let's try another one. Let's say 10 in base 10. Let's convert 10 into binary. So for 10, using our positional places, you can probably guess now we have 1 in the 8th place and 1 in the 2's place. So our number is going to look more like 1010. So you may be wondering, if our binary system makes numbers seem so large, why then do we use it? Well, apart from the fact that computers rely on electricity either by switching circuits on or off, ancient Egyptians realized any number could be formed from the sequence of powers of 2. So if you wrote out the sequence of powers of 2, like 1, 2, 4, 8, 16, and so on, you could use this basically to find any number. 1, you already have 1. You have 2, 1 and 2 make 3. You have 4, 1 and 4 make 5. You have 2 and 4 make 6, and so on and so forth. So every single number could be gotten from this number, and using this, they devised easy methods of multiplying and dividing numbers without the need of times tables, which we need in our decimal system. So let's take an example. If we wanted to multiply, let's say 13 by 65. Let's go ahead and multiply 13 by 65 using the ancient Egyptian method. So what they'll do is they'll write out their sequence of numbers, 1, 2, 4, 8, 16, and once they get up to 16, the number with which we're multiplying, they stop, and they write out their multiplied number on the other side, 65, and on each other number they multiply by 2. So you have 65, 130, 260, 520. So how do you get 13? You get 13 from 8, 4, and 1. So you circle those numbers, and what are the corresponding digits? You have 520, 260 plus 65, which gives us 845. and go ahead and check that. 13 times 65, 845. Another example, let's take 14 times 37. So we go ahead and write out our sequence: 1, 2, 4, 8. And once we get to our number, we stop and we write down our multiplier, 37, and every other step we multiply by 2. So 74, 148, 296. So how do we get 14? You have 8, 4, and 2. And we add those numbers up: 296 plus 148 plus 74, 518. And go ahead and check that. 14 times 37, 518. Now to divide, they did relatively the opposite. So let's take, you want to divide 247 by 13. We go ahead and write down our sequence: 1, 2, 4, 8. And once we get to our number with which we divide, we stop. And then we write down 13. And we multiply each step by 2 again. So 13, 26, 52, 104, 208. Now we get our 247 from our numbers. You have 208 plus 26 plus 13. That gives us 247. And you add the corresponding numbers. You have 16, 2, and 1. So 247 divided by 13 is 19. And you can check that. So basically, this is exactly how computers think when you carry out calculations. So that's enough for now. In our next video, we're going to look at how binary numbers together with logic gates combine to make real magic happen, laying down the foundation for computer science and how computers think and function. So thanks very much for watching. Please consider to like, share, and subscribe, and also consider supporting us on Patreon or PayPal to help us continue making such educative videos in the future. Thanks very much for watching. Until next time, bye bye.